Let's perform the indicated operation. Thus far, it looks like these are unlike terms. But before we can make that decision, let's make sure each radical is simplified. I have the square root of 18, but remember, 18 contains the perfect square factor of 9. 18 is 9 times 2 minus 75. In 75, there is a perfect square factor of 25, and 75 is 25 times 3. Now, 3 has no perfect square factors other than 1, of course, so I simply rewrite that. It is simplified. And then 8 is 4 times 2, and 4 is a perfect square factor. Now let's go ahead and simplify. By the product rule for radicals, I can write this as the square root of 9 times the square root of 2. What is the square root of 9? The square root of 9 is 3, so I'll have 3 times the square root of 2 minus, by the product rule again, I can write this as the square root of 25 times the square root of 3. What is the square root of 25? It is 5, and then I still have the square root of 3 plus, just rewriting 7 square root of 3 minus, what is the square root of 4? It is 2, and then I have the square root of 2. Now, if you had trouble with this step, take a moment and write this, for example, as the square root of 9 times the square root of 2 minus square root of 25 times square root of 3, and so on. But now let's look at these 4 terms and see if we have any like radicals. The answer is yes, this radical and this radical, those are like radicals, same radicands, and notice this index is an understood 2, so is this one. All right, so what is 3 minus 2? 3 minus 2 is 1, so I have 1 square root of 2, or simply square root of 2. Then these two are like radicals. I have negative 5 plus 7, that is 2 square root of 3. And by the way, if you'd like, you can write this as square root of 2 plus 2 square root of 3. I can go no further though because these are unlike radicals.